Hey everyone, and welcome to Dr. Abu Art in Academy channel. Today we are going to discuss part 1 of the biostatistics, which talks about the definition of biostatistics, the usage of biostatistics, sampling, variables, and probability. So, before talking about why statistics is necessary for biology and medicine, it's better to look at the definition of statistics and definition of biostatistics as well. Then we'll come to the example. So we'll start with statistics. Statistics is the science which deals with the development and application of the most appropriate methods for collection of data, presentation of data, analysis of data, and making decisions based on the analysis which we have done. So in statistics, we are developing a methodology and we are applying it. So we develop the methodology how to collect the data. For example, we can collect the data through survey. We can collect that through interviewing of the people, interviews. We can collect the data through questionnaire, distribute questionnaire, and get the data. Then after we collect the data, we have to know how to present this data. So if we have a data which is distinct, for example, we have statistics about the male and female, so it is distinct, so we can present it as per chart. If we have statistics about the weight, so weight is a continuous, we'll come later to these details, so we can present as per chart, as a graph. So male and female, if it is distinct, it has to be per chart. If it is continuous data, it has to be graph. And some more details which will come in touch later on. So now we collect the data. We presented the data in a graph or per chart or pie chart or whatever, as a percentage in pie chart, or distinct data as per chart, or continuous data as a graph. So we have to analyze this data and manipulate the figure and interpret it. So to see in which year what happened, for which gender, what was the causes, during which duration or which age this problem or the disease happened. So we have to analyze and interpret the data. And then based on the interpretation and the analysis of the data, we can make a decision. This is in general the definition of statistics. But coming to biostatistics, it is a statistics science. It is just application of statistics, but for the issues which is related to the biological science. Some diseases, the thing which is related to plants, human, animals. So the things which is biological. Okay, so biostatistics, there is no difference between it and between the statistics, except for it is mainly related to the biological science. That's why the word bio is added. Before discussing this example, we need just to come in touch with two things which we have already taken in the high school, which is independent variable independent variable. It doesn't depend on anything. We can choose it. For example, the interval of the time. We can choose to have the experiment every 5 seconds. Okay, so every 5 seconds or every 10 seconds. So this is independent. We have to decide. We can decide. Usually we have or we can decide, but it's not always, because in some cases it's out of our control, but it is independent variables. Okay, so independent variables, the variables which it changes, or we are changing it. Then we have another variable which is dependent. Dependent variable, the variable which depends on the independent. For example, if I take the measurement every 5 seconds. So what is the measurement which I am taking? if I'm measuring the speed every 10 seconds, so what is the speed which I'm measuring? So dependent is depending on the independent. I think when we take this example, it will be more clear to us. Okay, so in this example of the blood pressure, here there are some variables which we are changing, or it is changeable. It's independent. We are not measuring them. They are changeable, and then they are impacting or affecting the blood pressure. And we are measuring the blood pressure, which is impacted by this one. For example, the environmental factor, the mood, the diet, the weather, all this may impact the blood pressure. So these are variable. If someone has a good mood, so maybe his blood pressure will be low. If he has a bad mood, maybe his blood pressure will increase. If he's eating a lot of fats, maybe he will get cholesterol and his blood pressure will increase. The weather, in hot weather, maybe the blood pressure will increase. So this is independent variable, which we can change it, or it is changeable. It can be changed, okay? So this is called environmental factors. Then all these factors has impact on the blood pressure, which we are measuring. Some other factors like the patho or physiological regulations of our body. So if we have genes, suppressed genes, which is not active, so sometimes it happens that induced activation or suppression of genes. So the gene maybe it is activated or suppressed. Activated and become active and working, or suppressed and stop acting. This may impact the blood pressure. The hormone and neural regulations, all this also will impact the blood pressure. So this is independent. We don't have control on them, and we have to measure the blood pressure. So blood pressure is the dependent. It depends on this factor. Also inherited factors. If it changed, the allele inherited, if someone had the allele which causes high blood pressure, so we can have an experiment and measure the blood pressure. Imprinted activation of gene, also it will impact the blood pressure. So let us now have this example in a different way, okay? Okay. So here, this is the parameter or the variable. Which we are going to measure, to be measured. Okay, examine the parameter. What is the parameter which you are going to examine or to test here? The variable. Parameter means variable also. The blood pressure. Okay, so we knew that the blood pressure for people, for human, it is 122 millimeter of mercury. 120 millimeter mercury. So what does it mean? Does it mean that everyone in the world, his blood pressure, the systolic blood pressure, should be 120, or could be more or less, or within this range or average? So here it says that everybody knows that the systolic blood pressure is 120 millimeter mercury. So what does this mean? This means that the systolic blood pressure of a healthy person is most likely, so it is not exactly, most likely to be 120 millimeter mercury. So we can have some people with more or less than 120. Of course, sure, we can have people more or less 120. So 120 is most likely, and usually this is what we are getting from the statistics. We're getting the probability. It is most likely or less likely, or it is it's something which is 100% certain, or something which is rare case or will never happen. So this is the outcomes from the statistics, or it is 50%, 35%, 25%. So this is the outcomes of the statistics. So if we say that the blood pressure for the people or for the human is 120, this means that it is most likely for the healthy people, of the people who follow the sample characters. If we made the sample for the healthy people, so this would be applicable also to the healthy people. 120 millimeter of mercury. Most of the above factors, which is environmental factors, impacting the blood pressure, but it is independent. The physiological regulation, independent. The inherited factors, it's independent. All these factors, in our case, they are independent factors. So most of the above factors are completely unknown. We doesn't know all these details for everyone. The inherited factors. When someone comes to you in the hospital, you don't know what is the inherited factors from the first visit. For the physiological regulation, also you don't know the activity of the hormone which he has, or whether it's induced activation or have some genes which is suppressed. Also you don't know the mood, the diet, which is, unless you ask him, but you don't know all this data for everyone. So most of the above factors completely unknown, not available when the blood pressure of individual is measured. It's not from the spot. When someone visits you, you have all these details about him. Most likely it will be unknown, okay, at the time of measuring the blood pressure. So it is impossible practically to make an accurate prediction, to say that this person, without measuring his blood pressure, using the biostatistics, that this person blood pressure will be 120, 118, 115, 130. You cannot decide accurately. You can say that likely he will be within the range of, if you know that he's coming from this area and this is their diet, he's from this family and within this age group, so you can say, okay, his blood pressure, I'm expecting that it will be within 120 or 120 to 130. It could be within this range, so you can predict it, but you cannot say accurately for this person it will be 118, 120 without measuring. So it is impossible to make accurate prediction about the blood pressure of an individual person. However, it is possible to make probabilistic prediction. You can say, okay, the people living in this state and within this age from 18 to 30, and they're eating this diet, they're most likely to have blood pressure within the range of 115 to 120. So, without knowing all the details, but you know that the alleles or the genes which is most likely available in this area from previous statistics, okay, it could be also applicable to this person, but it could be also not applicable to him. So you know that the diet, the mood, the weather in this area. So you know some of the factors or many of the factors which impacting the blood pressure of this person. So you can predict it, but it cannot be given accurately only from biostatistics. So biostatistics give us an idea about the range of the blood pressure of the variable or the parameter which we are measuring. So here, just to wrap up this page or this slide, here we have the blood pressure which we are measuring. So this is dependent variable, depending on other parameters. This parameter. So blood pressure depending on these parameters. Okay? So the variable which we are measuring, it is dependent. Dependent on what? Dependent on this independent parameters which inherited, which is physiological, which is environmental. So some of them I can control them. For example, the diet. I can ask the person to change his diet. I can change the weather. I can send him to another country or another continent. So the weather can be changed. I can ask him to use AC, air conditioned place, rather than staying outdoor in the sun. But some of them, like the genes, alleles, inherited genes, or dispersion of the genes, or activation of genes, we cannot control them. In this slide, we are going to discuss the random variables. Random variables here, that when we select, we cannot make a survey or statistics to the whole population. So, for example, I have this circle, this is the population, okay? But I cannot count everything inside this population. For example, if I assume this is all the people in one country, I cannot have the statistics or the details of everyone. So I have to take sample. For example, I assume that I have 1 million. I cannot do statistics for 1 million. For the whole population, every one of them, I cannot meet all of them or have a survey distributed to all of them, so I have to take sample from them. This sample has some of the characteristics that should be existing in it in order to be fair. So the first thing, that this sample should be random. So for example, I cannot go to the secondary school for girls and do statistics for girls school and generalize it for everyone in the secondary school, so whether it's boy or girl, because there are some characteristics for girls which is not applicable to boy. I cannot make a survey for in front of, for example, in front of what you call, in front of one of the prayer places, which almost most of the people go there are the old people, and generalize it for the whole population, because young people, they don't go there. So I cannot generalize it over the whole population. So I cannot go to nursery and make survey there and generalize it to all the people and say it's applicable to the old people or young people or to the parent, because I'm doing it at a nursery. So for the kids who are 3-4 years old. So I have to make sure that the sample is fair. So one of the fairness of the sample, that it has to be random. So I have to go to a place where I can pick a random sample. And random sample or random variable which I'm selecting. So random sample, I have to pick it randomly. For example, I have the men with heights, and I want to make a survey about the male and female. So I have this number of you. I can take one of them as a sample. So this is sample, and this is called population. Of course, it is not fair to have one person as a sample, and I can judge or determine or take decision based on one person as a sample, because he could be boy, he could be girl, he could be sick, he could be healthy. So I cannot decide based on one person. Okay, so let us here talk about the slide which we have here. The numerical data are necessary for mathematical description of the probability. Okay, a variable assigned to a number to a random event is called random variable. So what is the random variable? The variable which assigned to a random event of picking up a group of people. It is randomly, they will be randomly picked, so this is called random variable. Okay, so random variables, although they are randomly selected, but it can be two decisions or two groups. So one of them, that is it discrete random variable or continuous random variables. Discrete random variables mean that I don't have many options. For example, the blood group. Blood group could be group A, or blood group B, or blood group O, or blood group AB. I don't have any other choices. So this is called discrete variable, because I don't have many options. So the random variable, so this random variable means that I have more than one option, and I can randomly pick one of them, male and female. So I have more than one option. For the height, I have 190, 132, 134, 165, 182, 183, infinite number of possible values. Okay, so this is called continuous, but I have variety and I can pick any one of them. That's why it's called random. The same concept of the sample. If you have a sample of people, like this group of people, you can pick randomly any 2 or 3 or whatever number you want, but randomly. They can be picked randomly from this population. So the whole number of people called population. And we are picking just sample from them. In this slide, we are going to discuss why statistics necessary for biology and and medicine. If you look at the example which we have here, we have a population. This is the population. This population, first of all, let us get the definition of the population. Population is a set or a collection of individuals which we are interested in. So for example, I'm interested in checking the people who has high blood pressure. So my sample should be the people who have a high blood pressure. Then I can check in other diseases which is linked or related to high blood pressure. For example, I want to check the diseases which the people have between the age of 18 and 35. So my population will be this number of the people within this range of ages. Okay, so the population is the set or collection of all individuals, okay, which we are interested in. If I'm interested in the people who has high blood pressure, so all of them should be having high blood pressure. The people who are below 18, so I have to check the people who are below 18 years old. The people between 50 and 60, my population will be 50 and 60. Then in some cases, I cannot test or examine all the population. I have to select sample of them, and this sample should be random and should be fair in order to represent the sample. For example, I want to check the probability of the possibility of the people will elect one person of one of the election. For example, Donald Trump or Biden or whatever. I cannot go to one of the voting center which is known to everyone that they will be voting, for example, for Biden, and have select the sample from there. So my sample should be in a university, for example. So it would be in this case random and fair, because in university you will have variety of the people. They will have different opinion, different mind. They can vote for this person or vote for the other person. So we should make sure that the sample which we are selecting is random and it's fair also. Here, this is an example, the population which we have in some cases, and whether we are able to examine the whole population or no. For example, the mankind, all the people in the world. I cannot examine all the people in the world for any disease or for anything. It is practically impossible. All the breast cancer patients in the world, we have millions of people. I cannot have them as a sample, or I cannot examine all of them. So practically impossible to have everyone. And some of them knows that they have the breast cancer, and some of them doesn't know. I cannot have all the people. But if I said all the students in university, it could be in some university, it could be number of students, 7,000, 5,000, 3,000, it depends. So it will be difficult, but also it could happen, but it is difficult. So here it is impossible. Here it's impossible, but here in the university it is difficult. But if I said all females, so it's only females in grade 2 who are having the first year for them in grade 2, first time in grade 2, and the female only. So for grade 2, for example, I have 500 people, female 200 or 300 people. So it is visible. I can examine them, I can have tests on them, I can use them, the whole population. Of course, if I can use the whole population for any test or any statistics, it will be more accurate. If I have a smaller sample, it will be less accurate. If I have smaller and smaller, it will be lesser and lesser accurate in the accuracy. Of course, as far as we increase the number of population, the number of the people in the sample to be very closer to the population, so the result will be more and more accurate. Since biostatistics usually deal with large population, because this is related to bio, you need to treat a disease in one country or one location. So usually we are dealing with large number of population. It is usually practically impossible to examine all the individual in the population, okay, like the mankind, the breast cancer, and so on. So we have to pick a random sample. Okay, random sample is taken, but we have to make sure that it represents the whole population. If my population has a people who are 60 and 70 years old, and people who are 2-3 years old, and people who are 15 years old. So I have to make sure that when I pick a sample, it should represent all of them. It should be random, and it should, as much as we can, it should represent the whole population. We should not select a sample from a place. For example, I told you I want to check the sample for the population in a city. I cannot go to one of the kindergarten and ask and make the survey there. All the kids there are 3-4 years old. I cannot go to primary school or secondary school and say it represents the whole society, because society has people 50, 70, 60 years old, 40 years old, which is not existing there. So I can make it on one of the markets, in front of the school, in one of the clubs. So any place where most of the people are represented there. So I have to make sure that the random sample which I have represent the whole population. Statistics has to be used to draw conclusion. Once we have the statistics and we have the graph, we can see the number increasing, the number decreasing or declining. So I can draw a conclusion, get a conclusion, okay, about the whole population, because it is random, it's representing them. If I found 3 out of 10 having the disease, so I can say 30% possible will have the disease, because my sample is random and it represents the whole population. So it can be used to draw conclusion about the whole population based on the sample. So in this slide, we are going to talk about the sampling, and the sample has some condition to be available. Actually, this is called simple sample. Simple, because we have different types of samples. Simple sample. Okay, the simple sample, it has to be representative. What does it mean representative? It has to represent everyone. So every individual in our population, this one, any one of them should have the same chance, same opportunity to be chosen or selected. Okay, evenly. So this means that I will be randomly picking 1 or 2 or 3 or 4 or 5. So in this example, I want to pick 5. 1, 2, 3, 4, 5. Everyone in this population has to be expecting that he might be the person who will be selected. So we should not be biased and select only from this area or that area or one place. No. So everyone should have the same chance. So the sample should be representative. This is the first thing. What does it mean? It represents the people. Represent the population. Represent the population. So representative, everyone, every individual in the population has the same probability, the same chance of being selected, of being sampled. This can be achieved by random sampling, or called simple sampling sometimes. So the second thing here, on top of a representative, it has to be large. If we have a large sample, our data will be more realistic. If we have less sample, it will be less realistic. So if it's possible, I can do sample for 30% or 50% of the population, it will be well and fine. If I can do for 2%, 3%, it will be okay, but it will not be reliable. If sample even can go to very small, can be only 1%. It's acceptable, but the data which will come will be unreliable data. But it can be done, but it will be unrealistic and unreliable data. Okay, so the sample should be representative and large enough so that statistical conclusions are reliable. So reliability depends on the size of the sample. Okay, so here this is the population, everyone. Okay, so everyone here is the population. This is the selected sample, random sample, and this is each individual, and even the people here are individuals as well. Okay, so a sample containing one element can also be representative. It represents one person, but the conclusion based on this sample is not reliable because it is very small size sample. Okay, so as I can see in this example here, this is my population, everyone, and when I select the sample, I have to make sure that it is representative. How representative? So the blue color represented and this orange color is representative as well. Also for the other group, I have to make sure that all of them are representative. Okay, so here in the, for example, here I've already picked both of them from the blue color. It's okay as far as it is not intentionally picked from the blue color. So maybe both of them will be orange, maybe both of them will be blue color. It depends, but everyone should have the possibility or the probability to be selected. Okay, just something which is additional or extra, which we need to think at. Okay, let me get it in. Okay, so here if we looked at the sample, we have here sample which is called random sample. This is the one which we were talking about. So I can pick any, this is the population, the whole population. I can pick any one of them. I can pick the blue, I can pick green, I can pick any color randomly. So for example, I said I want to pick 5 people, so I can pick 1, 2, 3, 4, 5. In this 5, only one is green. It could be 2 green, 3, maybe the 5 are green, maybe 3 only are blue and 2 are green. So it depends, but should be random. Okay, this is called simple random sample. So the sample is random sample, but it is simple, randomly, anyone. Even if all of them will be green, all of them will be above 50 years old, all of them will be blue 18 years old. It is random. At the end of the day, it has to be random. There are some other ways like systematic random sample or systematic sample. Systematic sample means that I said, okay, I close my eyes and say I'll check number 1 and I'll skip 2 and check number 1 after that and I'll skip another 2 and next I'll select the next, skip 2 and select the next, skip 2 and so on. So here, for example, he picked this green one, he picked this green and skipped the 2 and pick the third, this one and skip 2 and pick this one and so on. Okay, skip 2 and pick 1, skip 2 and pick 1. So he did it in a systematic way. He doesn't know who's coming. Maybe it's green, maybe all of them will be green, maybe all of them will be blue color. He doesn't know who's coming, but he set the rule. Before doing the experiment, I'll select the odd number, I'll select the even number, I'll select 1 and skip 3, select 1 and skip 2, select 1 and skip 1, alternate. Or select 1 and skip 4, select 4 and skip 1. It's up to him, but he has to set the systematic way in front before starting the experiment. He has to say, I will select the first and the third and the fifth and so on, if odd number, maybe even number, maybe 1 and skip 3 or 2 or 4. It's up to him. So this is called systematic because he set the rule: select 1 and skip 2, select 1 and skip 3, and so on. Then we have another type which is called stratified sample. Stratified sample, okay? And we have another type which is called cluster sample. So we'll come to stratified now, but let us finish the cluster sample first. So cluster sample, I split the people into groups or clusters and then pick complete group, okay? So as we can see here, he split the people into groups and pick group as it is. If the group has 2 green, all blue, 1 blue and 2 green, 2 green and 1 blue, so select the full group. This is called the cluster. So he split them into clusters or groups and select one or two clusters. So here he split them into groups or clusters and selected this cluster and this cluster. A stratified sample is little different. So why stratified sample? In a stratified sample, he's getting the percentage. For example, I have 6 green and 9 blue. The total 6 plus 9 equals 15. So the total are 15. The percentage of the green, 6 divided 15 equals 2 divided 5 equal 2 divided 5. It means equal 40%. So 40% are green and 60% are blue. So when he come to select the sample, he will make sure that he's selecting the sample which is 40% green and 60% blue. Okay? So in this sample, in this example, he has 6 green and 9 blue color, so total are 15. So if he want select 5 out of them, so the ratio here 6 to 9. It could be written if we divide it by 2 here. So divided by 3, it will be 2. Divided by 3 equal 2. So it will be 2 to 3. This is the percentage, 2 to 3. So if I have 6 here and 9, okay, this is 6 and 9, so 2 to 3, okay? If I want to select here total 5, so the 5, out of the 5, 2 will be green and 3 will be blue color, okay? So I have to maintain the same percentage, or I can say, okay, the percentage to the overall 6 to 15, which is 40%. So I'll keep 40% green. And the blue color 9 to 15, which is 60%. So I'll keep 60% blue color. Okay? So in this slide we have what is probability. Probability means I have a favorable or recommended event which I wanted to happen, or I look at its happeningness. So I have a favorable event and I have total number of events. For example, I have 5 lollipops, red color, and the whole lollipop plastic bag is 20. So what is the probability? So what I'm looking for the lollipop which is red in color. So how many lollipops red in color in the bag? 5. What is the total number of the lollipops of all the colors? 20. So 5 divided 20. So on the denominator we'll put the favorable event, okay? The favorable character which I'm looking for, the thing which I recommend I'm looking for, okay? Divided the total number which is possible in the population, okay? So here, for example, I have this dice. This dice has 6 faces. Each face has a number. So if I set the possibility, it will be 1. So 1 is my favorite or favorable number now. So how many times it can appear if I throw the dice? It can appear only 1 time. So what is the total number of the possible ways that numbers will appear? 6. So it will be 1 divided 6. Okay? So we'll come in this in detail. An experiment has any mutually exclusive and equally likely outcomes. Okay? So I have n numbers. The total number, which here the total number for this dice, it will be either 1 or 2 or 3 or 4 or 5 or 6. Any of these numbers, cannot be anything else, right? Yes. So if I said it is odd number. So how many odd numbers I have? I have 1, 5, and 3, or 1, 3, and 5. So I have 3. Could be this one. Which is one? Could be this. Could be this. 3. The total possibilities, because my favorite or my favorable event is odd number. So how many odd number could happen? 3 odd number. So the total number which could happen, whether odd or not, 6 number. 6 number. So here we ask ourselves about the total number of events, regardless of the favorable event which we have or the favorable character. This will be down in the denominator. And what is the favorable one, which will be what we are looking for? It has to be in the numerator on the top. Okay. So an event is defined as the sum of those outcomes which possesses a trait. For example, you have a trait which is odd number. This is the trait. This is the character which I'm looking for, or the trait which I have. I said, look, I'm looking at the people who have green eyes, so I can count them how many number, divided by the total number of the people who has green or blue or black or whatever number. Okay, all the people in my population or in my sample, to be more accurate. Okay. So the number of the outcomes, for example, I have 5 people with green eyes, and total number is 100. Total number of people of different color of eyes, 100. So the what I'm looking for, the outcome, the people with green eyes. So this is my favorable trait, my favorable character, my favorable outcome. So this will be at the top here. So the probability equal the number of favorable outcomes divided the number of all possible. So if say that I have 5 people with green eyes, so 5. Total number of people with any type of any color of eyes, 100, for example. So it will be 5 divided 100 will be 0.05. The probability always, it has to be between 0 and 100%. Okay, or between 0 and 1. So it could be 0.1, 0, 0.1, 0.2, 0.3, and so on, up to 1. Cannot be more than 1. Okay. Okay. So another example, I have in this example, the genotype of the parent is A capital is small and A capital is small. I'll get out the gametes, which is A capital here is small, A capital is small. So we will get the genotype of the new offspring, the new generation. Okay, the genotype could be A small, A small, or A capital is small, or A capital is small. So we'll have here this 4 possibility. So the probability that a randomly chosen offspring, the new offspring, not the parent, the offspring has at least 1 copy of allele A capital is how much, what the percentage, or what is the decimal, the probability. So has at least 1 copy of the allele A capital. This one has 2. He said at least 1. So it is he already has 2. This has 1. This has 1. So I have 3 out of. So my favorable outcome, my favorable character is the people who have allele A capital. So the total number is 3, which is K. I'm calling N small or K. And N capital, which is the total sample number, is 4. I have 1, 2, 3, 4. Whether it is having A capital or doesn't have A capital, 4. So the probability will be 3 divided 4 equal 0.75, or can times by 5 by 100%, and get 75%. Okay. I hope this one also is clear. In this slide, we will be talking about the probability and the relative frequency. So in order to understand the relative frequency, let us take this example. Okay, so this is the example, the example which we'll be talking about. Okay, if you look at this example, we have two tables. The male who scored the male, and this is the female and total. Okay, and this is the grades. They have scored grade A, grade B. Some people got grade C, grade D, grade F, and this is the total number. Okay, okay. So we have 9 males in this group. Male and get A. 9 of them get A. We have 18 male and they got B, and so on. Okay, so what is the relative frequency? Relative frequency means how many of them got A, for example, to the total number of the doing the experiment, whether for male or for female. So for example, if he say that, let us take this example, it will make it easy. So here, what is the percentage of the participant earned a score of A? I see what he didn't say male or female, so I have to take the total. So who scored A? Score 21 number. So 21. And what is the total number of the people who scored any grade, whether A or B or C or 80? Okay, so it will be 21 divided 80 equal 0.2625. Okay, so they put it here in this table, so it will be 0.625. If I want to get the people who scored B, so 32 divided 32 divided 80, so it will be divided 8, 4 divided 8, 10 divided 2, 5, so it is 40% or 0.4. Okay, so here it shows 0.4. So the relative frequency will get the number of the criteria which is looking for, grade A or grade B or grade C, divided the total number. Okay, okay. So let us go back to this example. In this example, you see what is the percentage of participant earn score A? How many earned A? 21. So the total number is 80. So here, this is called a relative frequency. So 21 divided 80 equal 0.625, 0.2625. So this is the percentage for the students who scored A from the participant. Okay, what is the percentage of participant earn score B or C? So I have to get the percentage for B, and or means plus. So for okay, let us clear this one. Okay, for the student score B or C. So for B, it will be 32 divided the total number, 32 divided 80, plus, because or, not and, not that both of them will happen at the same time, means and, or means this one or the other one. So the two are okay. If he scored B, he will be counted. If he scored C, also will be counted. So this is the one which is called B. If he scores C, he will be 19 divided 80. Okay, so the total number will be 0.4 plus 0.2375, which is equal 63.75, which is this one. So here, this is the relative frequency here, 0.4, and this is the other one. How we got this 0.4? 32 divided 80. How we got this 0.2375? 19 divided 80. If you want to get both of them, so he will sum both of them. This is called the relative frequency, and so on. So if he said what is the percentage what is the percentage of participant male were male? So where is the male? This is the number of the male. Okay, this is the total number of males, 38, because he didn't say male underscore A or B or C, he said only male. So male 38 divided 80, which is less than half. 38 divided 80, which is almost 47.5 percent. Okay, so what is the percentage that you were female? I'll get female. 42 divided 80. It should be 52.5%. It should be complementary to this one. This should be 100%, because I don't have any other category, either male or female. So these are the choices. So the sum of them should be 100%. So what is the percentage that the participant were? Male and got A. I see male here and got A. So this is the one. Okay, clear? Male and got A. So this is the point. So it will be 9 divided the total number. 9 divided the total, not divided this total, divided the overall total, 80. Okay, which is more than 10%, which is 11.25. What is the percentage that were female and got A? We'll see. Female and got A. So this one, which is 12 divided 80 equals 15%. I hope this one is clear, and we'll come and touch in detail to all this calculation of the probability in the next slides.